when you learn the Gauss-Jordan algorithm, in algebra, how do you solve the system equations? If you have 3 variables, 3 equations, you use so-called Gauss-Jordan elimination method. Each time you just reduce 1 variable. And the calculation you did is exactly what we said here, the 3 rows. The 3 rules. What are 3 rules? The first, you can interchange 2 rows of a matrix. That is the same as you interchange the position of 2 equations. You can put it whatever order you want. The second, you can multiply any row by a non-zero constant. Of course, if you have the x plus y plus z equal 1, you can have 2x plus 2y plus 2z equal 2. You multiply the constant, won't change the solution. The most important, you can add a scalar multiple of a row to another row. Now look, how do I eliminate this equation? I'm going to add the first equation to the second equation. 2x cancel out the negative 2x. I get this new equation. And that's the same rule. You can add a multiple of 1 equation, just neglect the x, y, z, because the computer never knows x, y, z. They only know number. Then you're going to add the number to the next row in the corresponding position. That's okay. Keep these rules in your heart, and then instead of use definition to find the inverse by solving a bunch of equations, it's much easier to use our rule here, the algorithm, to find the inverse simultaneously, not 1 by 1. The operation is carried on like this. You start from a n by 2n matrix. Now, if n equal 2, then you start by a 2 by 4 matrix. You put the A and I side by side. Because A itself is 2 by 2, I, the identical, is 2 by 2. Now you can see this is a 2 by 4. There's 2 rows, 4 columns. And then what you do? You apply this Gauss-Jordan algorithm, do whatever you have to do. Your goal is to change this by applying just like you solve equations. Change this matrix, put the I to the left, and then the other side, what you get, the B, is going to be the inverse of the A, if you can find the I. But how about if you cannot find the I? Unless you did something wrong, that's perfectly fine. If you cannot find the I, means the inverse does not exist. Just like you cannot solve the equation, it's not necessary you made a mistake. It's simply maybe the equation have no solution. That's true too. So let me give you the example slowly to work through. In this example, I want to find the inverse of the left side matrix. Then I put the left side with an identical matrix side by side. You know, the left side is 3 by 3. Right side is 3 by 3. Then you got the what? 3 by 6. What's your goal? Your goal is to apply the Gauss-Jordan algorithm to make it look like this. Oops. Make it look like this. Identical, now moved to the left side, and whatever you fill this blank is your inverse. Now, you just look at your beginning, look at your end. you play the puzzle by using the algorithm. Follow the rule. So the rule is you want this element be 1 first. That's called a pivot element. That's -3. You can divide by -3 to make it 1, to make this 1/3 ugly. Then you use the first row. You swap these two. You swap these two. I will call it the first row exchange with the third row like that. And what you get is 1, -1, 1, 0, 0, 1. And then the second, that's another change. The third one now is the first. Let me change this color in the middle. Oh, no. This is the line to separate the two. Okay, you got the 1. Then you look, you need the 2 zeros here. You need the 2 zeros here. Then you're going to use the rule 3 to make this 0. Then to use the rule 3, all I need is add the first row to the second row to become the new second row. Add 3 times of the first row to the third row to become the new third row. So let me write it out. Well, the first row, that's not a change. You simply copy. That's not going to change. This element called the pivotal. And then 1 plus 1 is going to be 0. -1 plus 2, you see you have to do exactly the same operation. -1 plus 2 is going to be 1. 1 plus 2 is going to be 3. And 0, 0. And that's 1. And that's 1. And 3 times the first 3 times plus -3 is 0. -3 plus 5 is 2. 3 plus 6 is going to be 9. Wait a moment. Oh, that's -1. I copied wrong. See that? -1. So change this back. -3, you got a 3. And then 0 add 0 is still 0. And wait a moment. Oh, here's 1. You add this. That's 1. 1. Yes, that's 1. No, I just changed the row, did not do anything. Never mind. Okay, let's continue. The third row. Okay, here you go. That's identified the mistake. Sorry for that. I failed to copy this change. When you change it down here, 0, yeah, 1, 0, 0, finally. Because I swapped this down, and yes, that's it. So let me re-add. This is so good, so far so good. -1 plus this 0, that's 2, that's 3. Now that's 1. You cannot afford the 0, 0, 0. And now add to this 0 is still 0, 3, 0. Then 1 times 3 added to here is 3. Yes, we got this. Well, now I got the 2 zeros. The first column is good. we need to consider this as a pivot element to make 2 more zeros here and here. You get the nice one there. You do the same calculation. So I'm going to copy the second row because you won't change. So I add the second row to the first row. I make a 0. I get 1 here, 0 here. Then 3 added to 1 is 4. And 0 added to 0 is still 0. Add this is 1, that's 2. I need twice of the first row, the second row, plus to the third row, to the new third row. So 0 is still 0. That's negative. Negative 2 plus 2 is 0. Negative 3 times 2 is negative 6. Plus 3 is negative 3. And 0 plus 1 is still 1. And twice negative 2 here. And 1. We're pretty close now. Well, the last element, I'm going to make this as 1 to make this 2 equal 0. It takes too long. I'm going to let you finish the rest and bring out my result, because I'm afraid I could mess up a little bit of thing somewhere. So in the end, you're going to find that your result is this. 0, 1, 2, you look pretty much like what we have. This row is right. And then I need a calculation, make this is this, 1, negative 2, 1. And then this operation will end up the inverse of the A, which is B equal inverse A. So you identify the right hand, what you get, by making this as 1, this 2 as 0, then you end up this matrix here. It's the inverse. So to check, you just multiply, and the 3, 5, 6, 0, negative 1, negative 1, let me check at least 1. 3 times 0 is 0, 5 times negative 1 is 5, negative 5, negative 5 plus 6 equal 1. This is good. And then you can check out the element. Then you find the inverse. Well, I wish I could go all the way to the detail, but I'm afraid somewhere I could mess up a little bit.